Hello everyone, welcome to Exemplar Physics. In the last video, we have discussed about few basic questions like what is physics and what are physical quantities. In this video, we are going to focus on two other things. They are what is measurement and what are fundamental or base physical quantities. We will be also trying to learn their units and their symbol. So these two things which we are going to focus in today's video. So let's start a discussion. So what is measurement? Measurement is comparison of an unknown quantity with a known quantity. So what do we do in measurement? We compare an unknown quantity with known quantity. I could give you one example. Suppose if you are measuring a mass. And to measure mass, you are using a beam balance. So beam balance looks something like this. And there would be a needle here. So you need to hold the beam balance over this needle in order to measure mass. So on one side you will place unknown mass. On one side you will place unknown mass. And on the other side you will place the known mass. Say maybe 1 kg stone, 2 kg stone or 5 kg stone, so on. And when the needle stays in the middle, you will conclude that both are having same mass. So what are you doing here? You are comparing an unknown mass with known mass. And what do you say? This process is nothing but measurement. Let's take one more example. Suppose you are trying to measure length of the floor. Suppose you are trying to measure length of a floor. So length of the floor is unknown for us. So we need to compare it with some known quantity. So when I told some student to find the length of a floor, he started measuring the length of the floor with the help of his foot. And at the end, he told me that the length of the floor is 12 feet. The length of the floor is 12 feet. So this was one of the measurement done by one student. So what did he do? He measured an unknown quantity with a known quantity. Here the known quantity is what? Foot. So the result of the measurement for that student is how much? 12 feet. So what he has done? He has done a measurement. Now the result of the measurement will consist of two things. Number one, number. Number two, the basic known quantities with which comparison is done, and we call that basic known quantity as unit. So here 12 is my number and feet is my unit. So the length of the floor is 12 feet, out of which 12 is number and feet is unit. So every measurement will consist of two things. One, a number, and the second one is the unit. I have asked a student, suppose I asked some other student to find the length of the table. Okay, I have asked to find the length of table. Now this student, what did he do? He started comparing the length of the table with his handspan. And at the end of the measurement, he told me that the length of the table is equal to 5 of his handspans. So what is 5 here? 5 is the number, handspan is the unit. So the length of the table is 5 times of his handspan. So every measurement will consist of two parts. One, a number, and two, unit. So here the unit is handspan, here the unit is feet. Now there is a question. Is everybody's foot is of equal measure or equal length? Are the measurement by handspan of every person is of equal measure? The answer is no. Handspan of one person may vary with the other because everybody's parts are of different sizes. So because of this, a non-uniformity comes in the measurement, because what I have measured may not be same to what you have measured. So what is 5 handspan for me may not be 5 handspan for you. Maybe let us suppose that your handspan is longer than mine, so your measurement will be less than mine. This will cause confusion as well as uncertainty in the world. Hence, some standard units and measurements are needed that do not change from person to person. For the sake of uniformity, scientists all over the world have accepted a set of standard units of measurement. So we need standard unit of measurement. Let me write here. So you cannot take any unit you want. So in order to do measurement, you need to use a standard. You need a standard unit of measurement which is uniform throughout the world. The system of units which have been used now are called the system of units which have been used now are called International System of Units. International System of Units, which in short we call them as SI units. Okay, so in order to avoid confusion and in order to bring a uniformity, what we need standard unit of measurement, units for measurement. standard units for measurement, and the system of units which are being used, widely used now, are called international system of units, also called as SI units. Now in the last class we have studied that there are numerous physical quantities. There are many physical quantities, and for each physical quantity there would be many units. But it has been found that only a limited number of units are required for expressing any physical quantity. We need a limited number of physical quantities to express all other physical quantities. So we need not require many physical quantities. Only with a few limited number of physical quantities we can represent almost all physical quantities, and these limited number of physical quantities are called as fundamental or base physical quantities. This limited number of physical quantities are called as fundamental or base physical quantities. Okay, there are 7 fundamental or base physical quantities which we will discuss further later, and all those physical quantities which are derived from fundamental quantities are called as derived physical quantities. All units derived from fundamental, or let us say fundamental or base units, are called as derived units. Okay, all the units which are derived from the base units or fundamental units are called as derived units, and we will be discussing about the derived units in another video. So let us keep our discussion up to the fundamental physical quantities, and there are 7 fundamental physical quantities, and I would just like to add or tell you this thing, that the standard scheme of symbols, okay, the standard scheme of symbols for fundamental quantities was developed and recommended by General Conference of Weights and Measures. Okay, these fundamental base quantities and their units, their symbol has been recommended by General Conference of Weights and Measures in 1971. So the main purpose of this is to bring uniformity of measurement throughout the world. So let's see what are the 7 fundamental physical quantities. Let me write them in tabular form. So I'll write like this: fundamental physical quantities. How many are there? 7. So first, serial number, next fundamental physical quantity, fundamental, or you can also say it as base physical quantity, then unit, and then symbol. Okay, so let's start with the first one, very basic one. First, length. Okay, length having unit meter, having unit meter, symbol small m. Second, mass, unit kilogram, symbol kg. Third, time, unit second. Okay, we are writing here SI unit, unit second, symbol small s, small s. You have to denote them in this way itself. Okay, these are internationally accepted symbols, so you are not supposed to make any deviation in writing them. Fourth, electric current, electric current. Okay, unit is named after a scientist called Ampere, symbol capital A. The symbol for which are denoted for the name of the scientist are always in capital letters. You may or may not write this Ampere in capital letters. Okay, while if you are writing it in a sentence and it comes in a middle, so there is no need to write this in caps. Okay, but if you are denoting it with a symbol, then the symbol should be capital letter, because this indicates the name of the scientist. Number 5, thermodynamic temperature, thermodynamic temperature, unit Kelvin. Kelvin is also name of a scientist, hence the symbol will be capital K. Next, sixth, amount of substance. Okay, unit mole, symbol mole, MOL. Unit MOLE, mole, symbol MOL. Seventh one, the last, luminous intensity, luminous intensity, unit candela, symbol CD. So these are the basic or fundamental physical quantities, and these are their units and symbol. Okay, these units are very specific. These units are very specific and they have specific definitions for them. If you want to know about the definitions, you can write in the comment section. Okay, I'll make a separate video on them, but do not deviate while writing these symbols. You have to write the symbols in this way. Meter always should be written in small m, kg small, all small letters, second small s, ampere name of the scientist capital A, Kelvin name of the scientist capital K, mole all small letters, candela CD. So this was our discussion. In the next video, we'll be discussing about derived units and supplementary units. I hope you are enjoying learning. If you like this video, please share it with your friends and tell them about the channel. Bye for now.